Hello, everyone, and welcome to today's Brown Bag. Today we have Mike and Judy Ballard. There are over 10,000 vans, aircraft, planes flying today. These are kit planes in the experimental category and are referred to as RVs. These airplanes are approved for 6 positive G forces and 3 negative Gs, allowing for aerobatics, and will cruise at 200 miles per hour. These planes must be certified by an FAA inspector prior to their first flight. Mike will show you how to assemble one of these high-performance aircraft in your basement or garage. He completed his latest RV-8 last July. Mike served in the United States Air Force as a pilot from 1965 to 1970. He then flew for Delta Airlines and retired in 2002 after 32 years. With the enthusiastic support of his wife, Judy, who is also a licensed pilot, he began building aircraft in their basement in Lynette. The Ballards are both graduates of Auburn University and are active members of OLLI at Auburn. Mike and Judy, the floor is yours.
Thank you, Shawnee. Quite an introduction. On this slide, there's a lot of information there. Shawnee gave you a whole bunch in the introduction, but I'm going to cover a few extra things. This is the latest edition of an RV-8 that we built, finishing in July of this past year. Why did we choose this airplane is the first question that comes up. And we did a lot of research on which airplane we would like to build. There are lots of kit manufacturers out there, including this one, which is mostly all aluminum. They're fiberglass aircraft with retractable gear, and they're tube and fabric type airplanes that also fit into the experimental category. To further our investigation, we traveled out to Aurora, Oregon, which is where the manufacturer of this particular airplane kit is. And they know their business out there. They gave each of us a flight in an RV-8, and they call that the grin flight, and they use that as an advertisement tool because it's the grin that you can't wipe off. And it pretty much is true. Once you have a flight in one of these airplanes and experience all that it will do, you get that RV grin. The other thing on this particular slide is the word fossil down there, which is my call sign. The reason I got the call sign of fossil is because I fly with a group of guys, and I am the oldest one when we started flying, and still am the oldest one in the group. So my call sign is fossil. The RV that you see on the tail, that's the name or the initials of the gentleman that started the factory, Richard Van Gruzen, and therefore the airplanes that he designs are called Van's aircraft.
On the fuselage, yeah.
The RV is back on the fuselage, as you can see, and the particular model is the 8 that you see. So the staff here suggested we give a little background about our aviation history. And I'm going to let Judy take over this time and tell you about our 4 generations of pilots.
Thanks, Mike. I'm going to give you a very brief history of our family's involvement in aviation. The photos that you're seeing on the screen now represent 4 generations of Ballard aviators. And it all began with this young man, James Ballard, in the upper left corner. James is the father of Mike and Jimmy. James was one of the members of the greatest generation, and indeed they were. James served in the Army Air Corps in World War II as an instructor pilot in the T-6 Texan. So James was the first of these 4 generations of Ballard pilots. Next, I'm going to give you a quick glimpse of Mike's earlier background. When Mike was 6 years old, his father, James, took him for a ride in a Piper Cub. It was truly a defining moment in Mike's young life. He was awestruck, and he knew that when he grew up, he wanted to be a pilot. He built model airplanes and hung them from the ceiling in his room. He built remote control airplanes and he flew them. He was fascinated with flying, and he still is. When he was a freshman at Auburn University, he enrolled in the Air Force ROTC program. He earned his private pilot license here at Auburn-Opelika Airport in preparation for his commission in the U.S. Air Force and his slot in the pilot training program. This photo shows Mike standing in front of the T-38 training aircraft at Reese Air Force Base in Lubbock, Texas. The next photo is Mike's brother, Jimmy, who is a few years younger than Mike. Jimmy was also an AU and Air Force ROTC graduate. He served in the United States Air Force as an instructor pilot in the T-38. So now we have Michael and Jimmy, and we have the second generation of Ballard aviators. Okay, on to the third generation. This is our son, Nathan, who earned his private pilot certificate when he was 17 and about to begin his senior year at Auburn High School. He has gone on to earn more ratings, one of which is his CFI, Certified Flight Instructor rating. So now, along with teaching his flight students, he is also teaching his children, our grandchildren, to fly, which leads us to the fourth generation of Ballard aviators. We'll start with Jack, Nathan's son, our grandson, who is now 18 years old and will graduate from high school this month. Just a week and a half ago, Jack soloed in a Cessna 172. It was very exciting for Dad Nathan and grandparents Mimi and Papa. The next photo on the left is Hayden, our oldest grandchild, who is completing her sophomore year at the University of Georgia. Dad Nathan is now giving Hayden flight lessons, and her younger sister McCall, who you'll see in a later slide, is also showing an interest in learning to fly. So that completes the fourth generation of Ballard aviators thus far. I do see a pattern here. Okay, middle photo, bottom row. Here I am standing in front of Judy 3. A bit of background on how I personally got into flying. In the late 80s, Mike and I got involved in general aviation. We owned a couple of airplanes during that time. I had been an observer or actual passenger all these years of being associated with aviation through Mike. So in 1992, I made the momentous decision for me to learn to fly. I enrolled in the flight program here at Auburn-Opelika Airport. I had a great instructor in Bill Johnson, who was the head of the flight school at that time, and I was on my way. I earned my private pilot certificate in April of '92, and I was so motivated that I continued on and earned my instrument rating and my multi-engine rating. It was an intense and exciting time, but it also revealed to me, it was made perfectly clear, I now understood the absolute allure and sheer awesomeness of flying an airplane. Back to you, Michael.
After pilot training, I was assigned to fly this aircraft in Germany. It's an Air Force F-4D, assigned to NATO. And moving forward, I had nothing to do with building this aircraft. This is probably the last kick to promote our aviation, continued aviation. This is a very emotional photograph, and I'll share a little bit of that with you. This is an MD-11 arriving from England. This is my last flight for Delta Airlines. Down in this area was a group of fire trucks with the water cannons to spray in an arch as we taxied in. So we landed, we were about to land, and it was already an emotional flight with flight attendants with balloons. I think we poured champagne for everybody in the passenger compartment, and everybody at the airport is aware of what's going on since the fire trucks are out to spray the water salute. But the one that got me is when the tower said, Delta, one last time, clear to land. I think I almost broke up at that time, just like I am now. So let's get started here. This is the tail kit. We're going to build this RV-8, and the very first thing you get from Vans is these two boxes, cardboard boxes. And Vans wants you to purchase these 2 boxes along with a full set of plans before you make the decision to start buying the more expensive kits. But these 2 kits are the first 2 of many kits to come. These are also the least expensive of all the kits that you get. That particular box opened up and it's all packaged. It was fun opening, and here we go. Let's put it together. This is the horizontal and vertical stabilizer. All of these parts in those 2 boxes. And as you can see, everything is covered in this blue plastic film to protect it from any kind of grease, water, or any kind of oxidation. These 2 pieces right here are pieces that you actually make or build out of angled aluminum. These are the support pieces for the horizontal stabilizer. Moving along. There's the same piece with the skin cleco to the frame. I'll explain that the clecos are a temporary fastener to help hold everything together while you prepare to rivet. It's actually a 3-stage process. In the entire airplane, you will match drill the existing holes, you will dimple the holes, and then you would deburr the holes before you attach the flush rivets to the aircraft. This happens throughout the airplane, so I won't need to go through that again. So here we are with the next piece. That's the vertical stabilizer. And as you can see, we're taking some of the blue plastic covering off the airplane into these 2 areas to be able to get to the rivets that will go in there as we move along. This is a fun day. We've got 2 parts that are matched up, the rudder and the vertical stabilizer. That's fun when you get pieces that start to look like something that you recognize. All the tail pieces that you see hanging on the wall here, all of that came in the 2 boxes that we just unwrapped on the front porch. At this point, everything is put aside for about 2 years because that's the first time you will be attaching it to the actual aircraft. I will mention right now that this series of slides in this 45 minutes covers 3 years and 3 months. So it takes quite a while to do. And like I told you before, this is probably the easiest and most economical entry into the aircraft construction business. So we put those aside for future use.
Back. Airplane in the corner.
Judy wants to, you can point it out. Go ahead.
Well, if you notice in the corner over there, there's an orange and blue remote control airplane. It's probably 65 years old, I guess. It's not flying at the moment, but I thought some of you AU fans would like the color, so I'll just say a quiet war eagle right now.
Moving right along. The next box is not cardboard, but now they're coming in a plywood box. And this is the fuselage kit. And this is what they call a slow build fuselage kit. You can order these parts as what they call a fast build kit, where probably just less than half of it is completed for you. The 2 previous airplanes we built were quick builds. They go together a little bit faster, but on this one, I wanted to save a little bit of money. So we ordered the slow build kit, which looks like this over here as it's being unpacked. All right, Brother Jimmy is just taking the first pieces out of that fuselage kit. This piece will be the bottom skin of the floor of the aircraft. And here's he's starting to put some of the structural parts in the bottom. Here's the same piece, and that's the bottom skin again. And now we are adding these tower type structures. And this is for the landing gear. And you're trying to reinforce all this area to support the landing gear, which has a lot of stress on it, obviously on landing. And these white pieces here, powder coated pieces are the stress points where the landing gear will attach, the engine will attach through these fittings here. So we're trying to create the structure and the strength of the aircraft right now. This is the first time that the stainless steel firewall appears, and we'll start to attach it to the very front of the airplane. You can see that I'm working off of a picnic table. Everything is lightweight. It's all aluminum. So going from here, there's the same structure. This is the anodized aluminum spar box where the wings will attach in each end of this area right here. And you can also notice there's more structural steel parts added for the landing gear. And also notice that the color has now changed from that blue plastic look. You peel the blue plastic protective film off, scratch it with a Scotch-Brite pad, and then spray it with some protective self-etching primer. So this is done to preserve the airplane for long periods of time. If you had to tie the airplane down, for example, you don't want the insides getting wet, oxidation, corrosion. I will point out that many of the older aircraft do not have this protective coating inside, and that's, if you were buying an aircraft, you would want to look well inside of an aircraft to make sure you didn't get one that had corrosion. So as you can see, the fuselage is getting bigger. I now have two picnic tables. These are the side pieces that are starting to go up to establish the sidewalls of the aircraft. And more of it has been self-etched, as you can see here. I will point out that all these tools over here on the wall are just normal, everyday screwdrivers and pliers and that type of thing. These are not things that you have to build one of these aircraft. I'll let Judy take this one as the fuselage gets bigger.
Well, there's Jack inside the plane, and there's McCall. It's amazing to see these photos because they're just pretty much grown up now, but they're helping Papa with the assembly of the fuselage.
And you can see that the tail surfaces are still up there hanging on the wall, not yet attached. And at this point, they've probably been hanging, we're probably close to the 9 months to 1 year point in the construction.
Okay, here are some OLLI friends. Y'all will all recognize Shigeko. It's the few Ks and a few Ks. And I had gotten to know Shigeko through the OLLI classes, and such a lovely person. And I told her about Mike building an airplane, and she was so interested. And so she and her husband came up to Lynette and toured the Ballard aircraft, which is what we call the basement at that time. And she wrote an article for a Japanese news magazine, which is fun to have.
We don't have a Japanese translator, but we do have the article. We may get somebody to support us by reading that article for us in Japanese.
And yes, and then the next, so you can see the airplane has made some progress in the construction part, and you'll recognize these active members of OLLI, the Shirlings, the Dorches, and the Bros.
I think they had a drink before this. Okay, let's move on. Wings. Our watchful dog Blackberry is watching the wings as they arrive from the freight yard into the basement. And we open the wings box. And guess what? This looks just like a wing. And in fact, it does. This is a point where you need to understand the 51% rule. For this airplane to be certified as a kit aircraft experimental category, the builder has to build a minimum of 51%. In other words, he gets to build the majority. But this is the so-called quick build wing kit. And as you can see, it looks just like a finished wing. Next slide shows brother Jimmy, and that's the underside of the wing as we're attaching the bottom skin. But prior to this, we've put in lots of wires in this conduit as a push rod for ailerons. We've attached a lot of things on the back of the wing for the ailerons and flaps, pivot points, and then out on the tip, what you can't see, landing lights, fiberglass tips, and this end will eventually go in that box that I showed you earlier on the fuselage. This is a lower fuselage skin that's been primed, and Judy, as you can see, is helping me with the dimple process. This machine here, you put the dies in each hole and press this lever down to create a dimple in each one of the holes for the flush rivets that are to come. There's a big day when, as you can see, we've now torn off a lot of the blue plastic. We put rivets into the fuselage, and we've riveted this part of the fuselage together. So I got some of my neighbors and friends, brother, to flip it over to be able to work onto the bottom of the fuselage, which is right here where that landing gear goes and attaches to those high stress points that I mentioned earlier. That's a big day to flip the canoe. Here's that landing gear. This is starting to become heavier. I need help now to move it around. This landing gear is all steel, 18 pounds each, and it takes up the load of a landing when you land. So this is being attached to the bottom. Here's a big day. Also, once you get the landing gear on, as you see, this is called flipping the canoe. And everybody that gets to this point in construction always says the same thing. Next time this is upside down, I will be flying it. In other words, you're going to be in an aileron roll or something like that. Henceforth, the aircraft will be worked on in this position right here, upright. And with the legs attached, the airplane becomes more than just a pile of parts. All airplanes are starting or will be referred to ultimately as a she. She takes on a gender at this point. She's on her legs, we would say. All right. From there, all those parts have been hanging on the wall now well over a year, and we're starting to attach them to the aft part of the fuselage. And this is a very, very important part to attach the horizontal stabilizer to the fuselage with everything squared up, level. You see, we got a level there. And this is daughter Rebecca helping me with that process. Horizontal stabilizer attaching to the fuselage, another big day. Vertical stabilizer attaching to the fuselage. As you see, I've got tape measures from here to here and from here down to here. And these measurements have to be exactly accurate to make this airplane fly through the air straight and true. Next slide, the first view of what's going on inside the airplane now. Here's another one of those steel tube powder coated parts that runs from the front cockpit to the back cockpit. A stick will be attached right here, a control stick. And the control stick will go in the back. I'm having a problem with the mouse. Okay, I got it. Right here is an aft stick. So the airplane can be flown from either the front or the back. This is a throttle for the back seater, and this is the throttle for the pilot in command in the front seat. You can also notice there's some plumbing starting to go in, and this is a selector switch to select the left tank or the right tank. The tanks are in the wings, and each one holds about exactly 21 gallons. So to keep the airplane balanced in flight, there's a lever here. You move back and forth every 30 minutes to burn 30 minutes of fuel out of one and 30 minutes of fuel out of the other. That fuel line runs up here and goes up through the stainless steel firewall up to the engine. Here's the installation of the black box, which is actually orange and hopefully never used. All the airlines have these, and we have one in this aircraft as well. This little orange box here is powered by a battery. It's always in the standby mode unless there's a crash, hard landing, or some reason for this to activate. It then will transmit on an emergency frequency for at least 24 hours your location. So you say it goes down in the woods or some other area and they can't find you, this box right here should help. And as I say, this is one of those you never hope to use. Here's an interesting photo. This is the rivet gun. We're actually riveting those flush rivets into the skin. That's Brother Jimmy with the bucking bar. And as I rivet, he holds the bucking bar against the bottom of the rivet, and we permanently attach this back skin in place. This back skin is called the turtle back skin, and it's covering up all the aft part of the aircraft where lots of wires and things have already been installed. I will mention that Rosie the riveter would be handling one of these rivet guns, and on the other side of that skin in the World War II aircraft, there's a bucking bar person to buck the rivets. I will also add that most of the World War II aircraft use round head rivets, which are much easier than these flush head rivets. Flush head rivets came about. Howard Hughes probably claims fame to this. He wanted his aircraft to go very fast, and the round head rivets that were protruding from the skin of the aircraft slowed the airplane down due to friction. So consequently, he put on flush head rivets, and we're trying to make the skin as smooth as possible on the outside to increase the speed and decrease the drag. It's summertime now, and it needs to be, because when this canopy is delivered, it comes in one big bubble. It's not split like this. It has to be split by the builder. And the best way to do this is outside when the temperature is 80 degrees or higher. You want this very warm to be cutting on the canopy. You can also see that it's also trimmed down at the bottom now. It comes with a big flange on the bottom. You have to cut all of that off to make it fit in the frame. Grandson Jack, this is the frame now mounted to the aircraft. We are positioning it for various pieces to attach so that it will roll back to enter and exit the plane. There's the same canopy. You can see the front half that we have cut off is now clecoed to the roll bar part, and the aft part is clecoed to the frame. You can also notice that we've now put a lot more pieces up here on the front, and they're clecoed in position, getting ready also to be riveted. At this point, the entire airplane is riveted together, and it's in place permanently, and we still have the blue skin applied to protect it. At this point, we're approximately at the 2-year point, and as I mentioned, this is a slow go process. There are some guys that have built these in less than a year, but very, very few. We built the 2 previous airplanes in about 2 years, and this one is going to take even longer. I think it has to do with age of the builder and ability to crawl around inside the airplane. So, I failed to show you this little NACA vent, they call it. This is where airflow goes into the cockpit to keep the cockpit cool when it's hot outside. And I will answer the question right up front. There is a heater in the airplane to keep you warm when it's cold. Moving forward, this is that stainless steel firewall. This is the engine mount, powder coated, and it's attached to the aircraft in these 4 points. I pointed out these stress points. There's a steel piece on the other side of each bolt to hold all of this in place. Also, this is a battery box. The builder gets to build this in its entirety, but they give you plenty of material to build it. Battery goes right here. So a lot of progress has been made, a lot you can't see at this point, but we're fitting seat cushions to know how high we need to be sitting so this canopy will close and we're still sitting at the proper height. This is also the point where everyone who builds one of these does the thumbs up and makes engine noises. This is the instrument panel starting to be designed. These are paper design sheets on the back of the instrument panel. And this is part of the structure of the aircraft right here to support all the skin. Okay, big item coming up, wiring. This is a wiring kit. They hand you a bunch of wires like this and a little kit. This is not nearly all of it. This is just a start. Some of these are pre-cut with fittings on them, but it gives you a start. And the only thing you can do here is say one wire at a time. If you do anything other than that and start saying, I'm building an airplane or this is going to fly next week, you're in trouble. Because this part for Jimmy and I'll show you, took approximately 6 months to build this wiring setup. And there's Jimmy hooking up one wire. I'm here with a heat gun to put some insulation on that joint to make sure that it doesn't come apart. I will also point out that at this point, unlike the 2 previous airplanes we built, all these boxes did not exist at that time. These are part of the Garmin system of engine instruments and navigation instruments and GPS. I can go on and on. These boxes do everything you can think about doing in an airplane. These black boxes up here are fuses to power all of this. And if you get a short or broken wire, the fuse will pop and whatever unit it is supplying power will no longer work. So 2 fuse boxes, a bunch of wires, and Garmin. All right, try to remember that, and I'm gonna get to the slide and show you the old way of doing it. Here's this instrument. After 6 months, this is such a big deal. You call all the grandkids, all the neighbors, everybody you know. This is the first time you'll apply 12-volt DC to the entire system. The battery's in, and all you have to do is turn on the master power switch, and everything's going to be powered. So you see everybody's all exciting, and guess who's the most exciting? Mike right here is very excited right here. We turned it on. This is what the instrument panel looks like. I may as well point out right here, this instrument has all the engine instruments, which are required to be monitored at all times. And then this part helps you fly the airplane, attitude indicator, altimeter, that sort of thing. Over in this half is a moving map display, and it will automatically show other aircraft in the sky. It will show weather. It will show instrument approaches, maps of all kinds. Everything is right in this one box right here. It's powered also by boxes that are back in the tail of the aircraft for transponder and other electronic items that come to this one box. So I know the question is, what happens if this goes out? Well, of course, we don't want it to go out ever, but we've got a standby over here on the right. It's a little, another Garmin instrument, and it has almost all of these capabilities over here. So you can fly the airplane just fine with this little gauge over here, but obviously you don't want this one to fail. This is called, I didn't mention this, is called the smoke test. You turn the switch on and you don't want it to smoke. So this smoke test we passed and instruments worked fine.
And Jack is.
Oh, yeah, Judy just pointed out the young generation. This is a touch screen. You see this hand right here? That's our grandson, Jack, already touch screening it and trying to change some setting on the thing before I even get it turned on. Okay, big item. You tell about the date of that, well, I'll get a drink of water.
Well, this is a big day, as there are a lot of big days building an airplane, but this is when the engine arrives, and it's around Christmas time. So I put a red bow on it and said Merry Christmas. Mike's pretty excited there.
This is well into 2 years, plus 2 years plus when we
Yeah,
received this. But this had been ordered probably about a year. So big day just prior to Christmas. Next photo is taking that engine out of the, oh, guess what? A cardboard box and putting it on the airplane. I couldn't believe it's shipped this high dollar engine in a cardboard box, but there you go. It was actually substantially packed because they foamed the entire outside of the engine, keep it immovable inside that box. And actually they had various monitors on the box itself to see if it was ever turned over in shipment. And it also monitors the moisture inside the box. The engine is mounted with those 4 bolts holding it on. And I will point out this, I'll point out something that Vans points out. Definition of this Lycoming is 180 horsepower, air-cooled aircraft engine, 4 cylinders, Lycoming, built in Pennsylvania. In my opinion, this is one of the best investments for this entire aircraft, because there are those, and for you builders out there, I would recommend, highly recommend a new engine. Don't try to rebuild something that's not approved in the design of the aircraft. Some people even try to use automotive engines on the aircraft. Bad idea. So it is now hanging on the engine mount, and we're moving forward. Another big day, first time out of the basement. She is now on her feet, as you can see, and all the blue skin is still attached. But the reason you really pull it out, other than joy of just rolling it out in the open air, is there are GPS antennas on both the front and back. And this is so the GPS antennas can see the sky. So we can check out all the navigation systems of the airplane by having it outside to look up the GPS satellites. Fun day just because we got it outside, however. You can also see the engines now in place with exhaust pipes ready for the prop as we move on. Here we are, we moved it from the basement up into the garage. And these are the wings that are now mostly finished, and we're fitting them to the airplane. They slide into that gold anodized box I pointed out earlier. And there's 2 more attach points besides these structural attach points, which the structural part is right here at the base of the wing. There's an attach point at the front and one at the back of the wing. So with the wing fastened temporarily to the spar box, these other 2 bolts are drilled in the proper place. And to determine the proper place of these 2 holes, plumb bobs across the leading edge of the wing, lots of leveling devices, digital levels, that sort of thing. And both of them have to be exactly equal, both in angle of attack and angle of incidence. That again makes the airplane fly straight and true through the air. So once these holes, attach points are drilled, we're going to return to construction in the basement. But I would point out that the bolts we used here for practice, we call practice bolts, and they're hardware bolts, and they're less diameter than the actual bolts that hold it on. In fact, the actual bolts that go through this spar, most people will freeze these bolts and put a little bit of lubricant on them to attach the wing to the aircraft. They are very, very close tolerance, and they're hard to get in if you don't do that. Cowling. This is a fiberglass, and can I say, I don't like fiberglass. Fiberglass is so messy because there's so much sanding and dust involved. But nevertheless, Vans Aircraft said, if you're going to build this, you're going to do fiberglass work, electrical work, epoxy work, metal work, sheet metal work, and engine work. So in that respect, this cowling comes in two pieces. It has to be trimmed all the way around to fit in your airplane. And then the two halves are attached together with a piano hinge right along this line. I'm trying to do this right along this line. And to take the cowling off, you can pull the piano hinge pin out, and then the top half will separate from the bottom half, and you can do maintenance work on the engine and that sort of thing. As you can see, some of those wires are now hanging out here. They go out to the wings, wing tips. And I'll also, like I said, I don't really like fiberglass, but you have to do epoxy and fiberglass around the windscreen, and you can see some of that taking place here. Also across the top of the windscreen. The canopy slides forward, fits up into this windscreen area, and that's an in-flight position right there, obviously. This epoxy mixed with fiberglass goes on. You sand it a multitude of times, and then between each application, more sanding. It's really dusty. Here's the prop. Grandson Jack helping me put it on. It's basic. This is a fixed pitch prop, and it is not a constant speed prop. Constant speed prop was on the two previous RV8s. The constant speed prop, you can adjust the pitch of the propeller to provide a little more takeoff power and a little faster cruise. And that's great. And I did that on the two previous aircraft. But this one is fixed pitch prop, which has been tested by Vans on this particular aircraft. And it does just fine. And it's also the one they recommend for the aircraft. The kicker is that constant speed prop, I won't give you a number, but the expense to get a constant speed prop is significantly more than this prop, which is a fixed pitch prop. If you want to know the cost difference, go look up the controller for the prop and the constant speed prop. A variety of manufacturers make these props. This is a Cincinnati 85 pitch prop, if anybody really wants to know. We're getting close now. We're over 2 years. We're about 2 years, 9 months when we start this process. Blue skin still on, loaded up. Let's go to the paint shop. Here we are at the paint shop. This paint person does mostly automotive, and I asked him if he wanted to paint an airplane. He said, "What?" I said, "You want to paint an airplane?" He said, "Sure." So here we are at his paint shop. We used automotive paint, which works just fine. I'll tell you straight out, it came from the Napa automotive store, and it's a good paint. But what happens, the process is we tear all the blue skin off, close to 3 years into it. All the blue skin, protective skin comes off. And right here in this area, you can see it's a little different color. I don't know how the photograph shows that well to you, but we are taking a Scotch-Brite pad, and this nice shiny skin is being scratched. And you scratch the entire airplane, and you clean it all off. And then you start with the various layers of primer and base coat and color coat and clear coat. So that took place in his shop over a period of about a month. This is the painter. I think he's probably online with us. So there you go, Tommy. You're on TV. He's painting the cowl, obviously. The blue and white design came from Judith, and he's just about ready to tear all the paper off, move back to the hangar or the basement. Here we are, the plane has been painted. And guess what? We're going back to the basement, not quite finished yet. So back in the basement, these two guys are applying the 1943 Stars and Bars decal along with the RV8s Judy, I'll let you tell about the
Okay.
red tail.
Okay. Our previous two airplanes were painted similar to P-51s, the World War II airplane that Mike and I both think is the best airplane ever built. And this time we decided to paint the tail red, as you can see, in honor of the Tuskegee Airmen Red Tails. So we've got the cows going on. We've got our names on the canopy skirt. My call sign is J3 after Judy. So we'll get to more about that later. Oh, just in case you want to remember Mike's birthday, the N number of the airplane is 713 Mike Bravo. Well, that's July 13th, Mike Ballard.
So I'll be expecting gifts from everyone on July 13th. Thank you very much. Okay, guess what? Traveling time again. The cow's on, the airplane is painted. And in the life of a builder, this is the biggest day for the last over 3 years. Here we go, leaving the neighborhood. Nobody even said goodbye.
Traveling to Harris County Pine Mountain Airport in Georgia.
Okay, at the hangar, wings already there. We took them over previously. I didn't point out earlier, but this interior is lipstick red, and all the two previous airplanes and this one had the same interior, lipstick red. And I'll point out why that's significant later. Fuselage made it to the airport, unloaded. Let's put it together. Okay, wings attached. Tail is on, engine is on, engine cowling is on, prop is on, spinner is on. And I'll let Judy describe the significance of what's going on with all this nomenclature on there. You got.
Well, her name is Judy 3, and the previous one was Judy 2, and the first one was just Judy after guess who. But anyway, if a certain age person remembers in some old movie the actor saying Judy, well, that's where that came from. And we wanted to have a colorful airplane, or at least I did. And so we took a little artistic license here. It's not exactly like how P-51s were painted at that time, but it was fun. And the decal right below the Judy 3 is the one of the patches from Mike's squadron in Bitburg, Germany, the 53rd Tactical Fighter Squadron, and there's one on the other side. And what else? Yellow invasion stripes on the wings.
Yellow invasion stripes, which were painted with the red tails. So I will point out right on this photograph, you see the tires are on, and there are no wheel pants here. If you visualize this airplane traveling through the air at 180, 200 miles an hour, this part of the tire is just blunt force going into the wind. So it creates lots of drag to push these tires through the air. This is not a retractable gear airplane, and we're trying to make it go fast, the need for speed and all that stuff. So we want to eventually cover this up, but for now, we're going to leave it exposed like this because we want to create some drag, because when we fly, not only are we testing the airplane, but we're breaking in a brand new engine, and we want to operate that engine at a high power setting without exceeding the maximum speed of the airplane. I hope that wasn't too technical. First engine start, another big day. This is about 3 years and 2 months into the process. And Jimmy was standing by with the extinguisher, and it cranked on the second blade. I was proud of that. After priming, 2 blades turned over and it started right up. I will point out right here that everybody that flies tail draggers, if you start an engine and it goes to an excessive RPM because of some setting, the airplane tail will actually fly unless you hold it down. That's an elevator right there. As you can see, as the airflow goes across the top of that, it's pushing down on the tail. This is also the way you taxi an airplane. You hold the stick full aft to achieve this elevator in the down position. So I'm holding the elevator down with the stick and watching all the engine instruments. Thank goodness everything worked fine. The biggest day. You want to take this one or not? Yeah, and this is the airworthiness certificate after an FAA inspector or his designated representative come to the aircraft and looked at the airplane for 4 hours with mirrors, magnifying glasses. He's underneath. He crawled into places I could not even get to. He was a little bitty guy, but he looked at everything. He also inspected all the bill logs, photographs. He didn't look at all of them, but I have 2,300 photographs of the build of this airplane. And at the end, he issues this one piece of paper, the airworthiness certificate, which allows us to go fly the airplane in a restricted area. And that restricted area is defined on the bottom of this piece of paper here. My restricted area is most of central Alabama. I could go all the way west to Tuscaloosa and up to Alex City. But that's still a very small area when you consider you're operating at 180, 200 miles an hour. I have to fly in this area for 40 hours, and it's called a phase 1 inspection by me, the pilot. And I have to make the airplane do all the things that anybody else would be expecting the airplane to do. Stalls, slow flight, high speed, high angle of attack, flaps up, flaps down, and all the aerobatic maneuvers that the airplane is expected to do, such as aileron rolls, barrel rolls, split S, loops, you name it. You have to do it to make sure the airplane will do it. And I do all this by myself and no other passengers on board. Okay, so we're at 3 years.
You've completed your 40 hours.
I'll go back. The 40 hours required. I just last week completed that 40-hour test of the airplane. So it's finally a go somewhere airplane with passengers on board. We can now get in it and fly to the West Coast, or some people do or did fly to England in it. I'll tell you more about that later. First flight, though, was very important. That's where we are. So, as I said, we're operating without those wheel pants, so we're going fairly slow, 150, 160 miles an hour. This is another RV-8 wing right here. Judy's in the back seat of this airplane. Johnny White's flying the front seat. He's the safety chase, and he's going to fly on this wing and look at alignment of ailerons, flaps, wingtips. They're looking for any vibration, flutter, any smoke, any oil leaks, or anything unusual. It looks like a bad day, but it was actually a beautiful day over at Harris County, Georgia, for this test flight. We flew for about 30 minutes. Everything's operating great. And as I say, anybody can take off, but can you land? And that's always exciting, the very first landing of an aircraft. Here's a photograph. Wait a minute, I think this is a video. It is. This is a video of the first landing for Mike Ballard in 713 Mike Bravo. I kind of get excited. As you can see, the main gear touchdown first. For all you pilots out there, that's a wheel landing. Now you see the tail wheel coming down now. Boy, I'm good.
One more
Okay,
time.
I won't show it one more time. I'm running out of time here.
Yeah, okay.
Okay, 3 years and 3 months, almost to the day. I'll show you a couple of things you do with the airplane once you got it. Here's the 3 airplanes we built. This is the one we just showed you. And this is a RV-6A. And as you see a little bit difference here, it has a nose gear, which makes it fly just a little bit different than the other aircraft. What else you do? With some training, you go out and fly with your buddies and do a little formation work. And this is one of those things where guys get together and say, let's go buy that $100 hamburger. So you get together and fly to a local airport restaurant, tell all the lies you want to, and then fly back to your home base. So formation flying is one of the big things we do. I think this was the Auburn fly-in a few years ago. We got a whole group of guys together and flew into Auburn to their fly-in. I'll point out right here that this is a fly-in, not an air show. The airport is not closed for fly-ins or picnics, that type of thing. But if you're doing an air show, whole different set of FAA rules, regulations. The airspace has to be closed, and nobody else can fly into a closed airspace. Visualize the F-18s, Blue Angels, or the Thunderbirds flying with this group of airplanes even around. So they close the airports for an air show versus flying. This is another gathering. All these guys, I think, were F-16 pilots, and they let me be the lead for this particular group because they like the colors of the airplane with my blue and black and white invasion stripes. This is over the Gulf of Mexico, and they went ahead and I think they did an article about that group of F-16 guys. Here's a real P-51. I'll put the photograph here to show you how big it is compared to how little our little airplanes are. This is a, Judy and I both say this is the best airplane ever designed.
Yep.
But that's a real World War II P-51, and we were privileged to get to fly formation with him that day. Judy picked that one up.
Well, we were in Sun and Fun a couple of years ago and got to meet Tuskegee Airman George Hardy. It was a real honor, and we told him about how we were going to paint our airplane in honor of the red tails, and he was very pleased about that. And he, I don't know, he's 90 something there.
I think 97.
I'm not sure, but anyway, and then the poster at the bottom is the 2013 official poster for Sun and Fun, and that was the our second airplane. They used it for the poster,
and several thousand T-shirts have this on the back of their T-shirts. That group of airplanes over the Gulf of Mexico, these are the F-16 guys. That's me, fossil over in the back. And this is that lipstick red interior we put in all the airplanes we built. I think that's why the person writing the article wanted this airplane in front to point out how colorful it was. I'll also point out right here, I've got that one box on the instrument panel. Look at all of this. These are called steam gauges because they are driven by air, vacuum, and other pitot tubes and that sort of thing. But this is the old way of aviation with this type of instruments. Compare that to what we just showed you back there with that one box with everything on it. Got to add this one. I'm about to run out of time. The gentleman from Los Angeles bought this and flew it over to England. And this particular photo is on the way home because he flew it over. It stayed there for about 5 years and came back. Kit Plains did an article on him and how brave he was. And I think he's probably online today. So hello, Mark. Mark Alberry flew this to England. It stayed there 5 years and it's back in Los Angeles at the present time. You'll notice this area, there is no place to land here if that engine quits. And you carry life rafts and all kinds of emergency equipment, but that's a very dangerous area that right there. I watched him all the way over and back. He had a satellite pinger so I could keep track of where he was. That comes to the end. I think I'm to the end of my time. I wrote down 2 questions. I know everybody asked, and the first question anybody comes to mind about this airplane is how far can you go? Well, the airplane is restricted by the amount of fuel, 42 gallons, but your body is not up to flying all of that fuel out. So Judy and I fly about a 2-hour flight and stop for gas and the physiological needs rather than staying up when you are very uncomfortable. We can do 2 legs in this, about 2 hours each, and we're in Dallas before lunchtime. So it gives you an idea of the range, and the fuel burn is around 10 gallons an hour. People ask, how high do you go? And the airplane likes to be at 7,000 to 10,000 feet because it's a normally aspirated engine. It's not a turbocharged engine. It's not a jet engine. It likes to breathe the same air that we do. And as you get above 10,000 feet, there it gets very thin and the engine doesn't like it and the passenger and pilot do not like it. So I'm going to cut this off right now without questions because I can see we've been out here an hour and I don't think I can tell you anything more unless we go into a lot of technical details. Shawnee?
Thank y'all for joining us today. It's been fun.